Here, x plus 2 whole square is a repeated linear factor. So when you have improper rational function, you have to write that as a sum of polynomial and partial fraction. Now what I'm supposed to do? I have to find the value of a, b, c, equating the linear factors to 0. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysore. So in our previous session, we have solved some problems on improper rational functions, also proper rational function, how to resolve them into partial function. So we will continue the same in this session today. So we will take few more problems on partial fraction, but before that we will recall what are the types we have to look at before resolving fractions. So now whenever we have a rational function and the denominator is of the type non-repeated linear factors. So that is type 1. Whenever the denominator is not repeating, when you have linear factors, then a rational function of this form can be expressed as a sum of two partial fractions, a by x minus a, b by x minus b. Suppose you have three linear factors, then you can express in this form. A, B, C or constant. So you have to find the value of the constant by equating these linear factor to 0. So when you equate these linear factor to 0, you will get the value for x, and whenever you substitute the value of x, you will find the values for the constant A, B, C. So then we will substitute it and we will write the solution of resolving a partial fraction. Suppose type 2, we have a repeated linear factors. So what we will do when we have a repeated linear factors? So suppose you have x minus a whole square. That means x minus a is repeating twice. So in that case, you are going to write the partial sum like this. So you are dividing a by x minus a and b by x minus a whole square. So if you have a repeated linear factors along with non-repeated linear factors, you will write it separately as a, b, c. So whenever you have a repeated linear factor, so there will be sum a by x minus a and b by x minus a whole square for x minus a whole square, and for x minus b, you are writing one more simple fraction, that is c divided by x minus b. So we will take a few problems on type 2 partial fractions today. So also make a note that whenever a partial or a rational function is given, that should be always in proper rational function. If it is not in proper rational function, or if it is not a proper rational function, suppose if it is not a proper rational function, that is, if it is an improper rational function, then you have to convert it into as a sum of polynomial and proper rational function. Then we will resolve proper rational function into simple partial fraction. So we will take up problems of type 2 and also some improper rational function in this session. So the very first problem here is 3x plus 5 divided by x plus 2 whole square x minus 3. Here x plus 2 whole square is a repeated linear factor. So you will be having two simple fractions for that, and x minus 3 is another factor. You will write it as a sum of other simple fraction. So how to write it? See now. So I will write 3x plus 5 divided by x plus 2 whole square x minus 3. So this can be written as a divided by x plus 2 plus b divided by x plus 2 whole square plus c divided by x minus 3. So this is how we write. We can see here. So you have x minus a whole square x minus b, then you can write as a sum of three partial fractions. Now just equating the numerator after taking LCM or after multiplying with the factors x plus 2 whole square, x minus 3 on both sides. So what we will get? We are left with x plus 5 is equal to, if you want to write the factors of this, just multiply this whole thing on your right hand side for each factor. Then you are left with, so you have x plus 2 here, it cancels with 1x plus 2. So you are left with 1x plus 2 and 1x minus 3. So when you multiply this for each factors, so write down the remaining factors along with the constant. So when you multiply this with b, x plus 2 whole square cancels with x plus 2 whole square. You are left with only x minus 3. So just write b into x minus 3. Next you have x minus 3 in the denominator for c. So when you multiply this, x minus 3 get cancels. So you are left with c into x plus 2 whole square. So take this as equation 1, this as equation 2. What I am supposed to do next? I have to find the value of a, b and c. That is, we are going to equate the linear factors to 0. I'll take here, I have x plus 2 is equal to 0. So I'll get x is equal to minus 2. Another one I have x minus 3 is equal to 0. That I can take it as x is equal to 3. So just substitute the value of x in the given equation to find the value of unknown constant. Now I'll put x is equal to minus 2. If you put x is equal to minus 2 in equation 2, what you will get? 3 into minus 2 is minus 6 plus 5. Here, if you put minus 2 plus 2 get cancelled, the whole term becomes 0. Here you will get a into 0 plus, if you put minus 2 here, it is minus 5. Minus 2 minus 3 minus 5. If you put minus 2 here, it will become 0. Therefore, it is c into 0. So, on solving this, you will get minus 1 is equal to b into minus 5. So, therefore, your value of b is 1 divided by 5. Next, we got the value for b. Now, in the same way, we have to find the value of a and c. Next, I'll put x is equal to 3 in equation 2. So, when you put x is equal to 3 in equation 2, what happens here? 3 into 3, 9 plus 5 is equal to. Here, if you put 3 in this equation, 3 minus 3 becomes 0. So, you will get a into complete equation becomes 0. And here also, b becomes 0. And there, if you put 3 plus 2 is 5. 5 square is 25c you will get. So, on solving this, again, you will get this as 14 is equal to 25c, or c is equal to 14 divided by 25. Now, you have got the value of c. So, whenever you doesn't know what value should I put in the equation, you can take a choice of putting x is equal to 0 on the equation. So, here I'll put x is equal to 0 in equation 2. So, whenever you put x is equal to 0 in this equation, see what happens, 3 zeros are 0 becomes. So, on your left hand side, you will get only 5. So, there you put 0. So, you will get this as 2 and that as minus 3. Next, plus b you have, b is minus 3. Next, c you have. So, you have c which is 2 square. So, that is 5 is equal to minus 6a minus 3b plus 4c. Just substitute the value of b and c in the given equation. So, we will get 5 is equal to minus 6a minus 3 by 5 plus 56 by 25. So on solving this equation, I'll get 6a is equal to minus 84 divided by 25. So therefore, a is equal to minus 14 divided by 25. So I'll get the value for a now. So I got the value of a, b and c. So just substitute the values in equation 1. So what I'll get here? I'll get 3x plus 5 whole divided by x plus 2 whole square, x minus 3 is equal to, so what is the value of a you got? Minus 14 by 25. So I'll just write minus 14 here divided by 25 here I'll write. So this becomes x plus 2. Next for b you have 1 by 5. So I'll write plus 1 divided by 5 x plus 2 whole square. Next for c you got 14 by 25. So you can write it as plus 14 by 25 x minus 3. So this is the solution for this rational function. So we have another alternative method to find the value of a. So when you have only two linear factors, then you can find any two constant. To find the third constant, I said you can equate it to 0. So you will get all the values for a, b, c. Since b and c are known, you can substitute it and find the value of a. So other than this also, we have one more alternative method, that is equating the variables or equating the literal coefficients. So if you expand this and if you multiply this, you can equate the coefficients of x square. So I'll just explain how you can find it easily how you can find the value of a easily when you equate the coefficient on your right hand side as well as left hand side of x square or x or constant. So here is alternative method, whenever you doesn't know the third constant, you can equate the coefficients of x square or coefficients of x on both sides. So let me write equation 2 here again. So what was your equation 2? That is 3x plus 5 is equal to a into x plus 2 x minus 3 plus b into x minus 3 plus c into x plus 2 whole square. So this was your equation 2. So you got the value of b and c. So this is you've already got. Now you have to find the value of a, but we don't have any linear factor so that we can equate it to 0 and find the value of x. So in that case, we can equate the coefficients. Equate the coefficients. Coefficients of x square or x or constant also to find the value of a, b, c. Now here in this case what I'll do, I'll just equate the coefficients of x square. So do you find any x square here on your left hand side? No. So there is no x square, means the coefficient of x square here, it is 0. In the right hand side here, you can find the coefficient of x square, because when you multiply this equation, this is what? X into x is x square. So you have a coefficient for a. So that is x square, the coefficient of x square. When you multiply all, that is a into x plus 2, x minus 3. You can multiply this as a into x square minus 3x plus 2x minus 6. So when you multiply this, you will get it as ax square minus ax minus 6a. This is how you will get when you expand this. So just equating the coefficient of x square on both sides. So when you multiply this completely, you got a coefficient for x square, that is a. Similarly, look at this equation. When you multiply, it is just bx minus 3b. So there is no x square term. So that is, therefore you don't have any coefficient of x square. But here, when you expand x plus 2 whole square, what happens? So when you expand x plus 2 whole square, it is x square plus 2x plus 4. So when you multiply with c, you will get it as cx square 2cx 4c. So you have a coefficient of x square with c. So therefore you can write this as c. So you will get 0 is equal to a plus c. So this implies what? A is equal to minus c. What is the value of c? 14 by 15. So therefore the value of a you will get minus 14 by 25. So you got a is equal to minus c. What is the value of c? C is 14 by 25. So therefore I can write a is equal to minus 14 by 25. So the same thing, just substitute the value of a, b and c in the given equation. So your a value was 14 by 25. So it is minus 14 by 25. B was 1 by 5. C was 14 by 25. So just you're writing the solution as it is. So this is one more alternative method you can find without equating the linear factors to 0. Just equate the coefficient of x square, x or constant in the given equation. You can find out the value of the constants a, b, c and substitute it back to the equation 1. So this is one method and here is one more alternative method. If you find this is quite difficult, you can use the same thing. Any one method is allowed. We'll move on to the next problem. X square minus 2, x square plus x minus 2. Here I say I cannot resolve this fraction. Why? Because this is an improper rational fraction. So when you have improper rational function, you have to write that as a sum of polynomial and partial fraction. So let me write this first in the form of partial fraction. So let me write this as a sum of polynomial and proper fraction. So how I'll write it? Just dividing the polynomial. So we get x square plus x minus 12 and here we have x square minus 2. So just both we have x square multiply with 1, we get x square plus x minus 12. Change the sign, minus, minus, plus. So x square get cancels. Here you will get minus x plus 12 minus 2 is plus 10. So therefore, this can be written as x square minus 2 whole divided by x square plus x minus 12. This is equal to, so 1 plus. So you have 1 and here you can write this as 10 minus x. So therefore plus 10 minus x divided by, so same denominator, x square plus x minus 12. So take this as equation 1. Now I want to find the partial fraction for this proper fraction. So now this improper fraction is converted into the sum of polynomial and proper fraction. Now I'll just resolve the second term. I'll just add the terms later. So now take only this. You have 10 minus x divided by x square plus x minus 12. Again you have x square plus x minus 12. So whenever you have a quadratic equation or a polynomial, just resolve into two linear factor. So this can be written as x square plus 4x minus 3x minus 12. So it is x plus 4 minus 3 x plus 4. So therefore this can be written as x plus 4 into x minus 3. So this is now 10 minus x divided by x plus 4 into x minus 3. So when you have two different linear factors, you can write it as a divided by x plus 4 plus b divided by x minus 3. Take this as equation 2. Now just equate only the numerator after multiplying with x plus 4 and x minus 3. So when you take this, you will get it as 10 minus x is equal to, when you multiply with x plus 4 into x minus 3 on both left hand and right hand side. So when you multiply here, x plus 4 get cancels. You are left with only x minus 3. Similarly for b, you will get x plus 4. So take this as equation 3. So now I have to find the value of b as well as a. So I said we have two methods. One is equating the linear factors to 0 or just equating the constants or coefficient of x or coefficient of x square. So I'll use the concept of linear factors equating to 0. So we have x minus 3 and x plus 4 here. So when you equate them to 0, you will get x is equal to 3 and x is equal to minus 4. Just put x is equal to 3 and x is equal to minus 4 in equation 3. So put x is equal to 3 in equation 3. So what happens? You will get 10 minus 3. 10 minus 3. I'll just write the equation here once again. That is 10 minus x is equal to a into x minus 3 plus b into x plus 4. Okay. So when you put x is equal to 3 here, a becomes 0 and b becomes 7. So this is 7 is equal to 7b. Therefore, b is equal to 1. Next, put x is equal to minus 4 in equation 3. Again, what happens? You will get 10 plus 4 because minus of minus 4 is plus 4. A into minus 4 minus 3 is again minus 7 and b becomes 0 because minus 4 plus 4 get cancels. So this side you will get 14 which is minus 7a. So therefore, a is equal to minus 2 you will get. Now you got a and b. Just substitute in equation 2. Substituting in equation 2, what we will get? Substituting in 2. So what was our equation 2? That is, we have written the partial fraction into two simple fraction. Now we got a and b. Just substitute the value of a and b. So what we will get? We will get 10 minus x divided by x plus 4 x minus 3 is equal to, so value of a is minus 2. So therefore it is minus 2 divided by x plus 4 plus 2 divided by x minus 3. Now here we have one more equation, that is equation 3, because this is not our rational function given. So what was the rational function? So this function. So how we have expressed this? As a sum of polynomial and proper fraction. Now proper fraction is expressed in terms of a and b. Just write the same in equation 1. So what we will get? So therefore again substituting in 3. Substituting in 3. So the question was x square plus x minus 12. So this is equal to 1 plus we had, but 1 plus 10 minus x plus 4 x minus 3. So 10 minus x by x square plus 10 minus x by x square plus x minus 12. Now this one we have resolved here. Substitute them back. So therefore x square minus 2 by x square plus x minus 12 is 1. This is minus 2 by x plus 4 plus 2 by x minus 3. So this is the answer. And what is the value of b? We got 1. So it is 1 divided by x minus 3. So this is the solution for proper fraction here, which 10 minus x by x square plus x minus 12. Now we got the value of AB, we have substituted in equation 2. So now for the rational function given, we will replace 10 minus x by x square plus x minus 12 with the new simple fractions. So therefore, substituting again in 3. So what was the rational function given before? That is x square minus 2 divided by x square plus x minus 12. Now already we have 1 plus, just replace with the AB values we got in equation 2. So therefore we will get it as 1. So replacing now with this minus 2 by x plus 4 plus 1 divided by x minus 3. So look here, whenever you have an improper rational function, first convert them into as a sum of polynomial and proper fraction. So after converting them as a sum of polynomial and proper rational function, then we will resolve proper rational function as in this case. So then again the same method of finding the constant. So substituting the value of b and a in equation 2 we will get. So in the place of 10 minus x by x plus 4 x minus 3, we'll just write the same value. Thus we have resolved the rational function. Next we have x cube minus 2 by x plus 1 whole square. So this is nothing but x cube minus 2 whole divided by x cube plus 2x square plus x. So you can see here the degree of the numerator as well as the denominator is same. That means it is an improper rational function. So therefore, first we have to convert them as a sum of polynomial and proper rational function. So let me convert this x cube minus 2, x cube plus 2x square plus x. So we'll divide it now. We have x cube plus 2x square plus x into x cube minus 2. So just multiply with 1 for this. You will get x cube plus 2x square plus x. Change the sign. Minus get cancels. Minus, minus. We have minus 2x square minus x minus 2. Or you can write this as minus 2x square plus x plus 2. Okay, so any of the thing is allowed. So now how I can write this? This can be written as, here we have a quotient 1. So 1. So in this can be written in the form of partial fraction, that is proper partial fraction. So this is minus, I'll write 2x square plus x plus 2 divided by x into x plus 1 whole square, or you can write this x cube plus 2x square plus x. Now this is in the sum of polynomial as well as proper rational function. So proper rational function means degree of the numerator is less than the degree of the denominator. Now what is the next step? I have to resolve the given proper rational function. So just consider only this rational function, that is 2x square plus x plus 2. Now the denominator can be written in this form also. So I will write this one. So x divided by x plus 1 whole square. This can be written as a by x plus b by, whenever you have repeated factors, for that you have to write b by x plus 1 plus c by x plus 1 whole square. So now take this as equation 1, this as equation 2. Just multiply the factors on both LHS and RHS. So you will equate the numerator as 2x square plus x plus 2 is equal to. So this one you will get it as a into x plus 1 whole square plus b into x plus 1 into x plus c x. So take this as equation 3. Now what I'm supposed to do, I have to find the value of A, B, C, equating the linear factors to 0. So what are the factors we have? One is x is equal to 0. Another one is x plus 1 is equal to 0. So therefore you will get x is equal to minus 1. First substitute the value of x as 0 and minus 1 in equation 3. Find out the constant values. So put x is equal to 0 in equation 3. So I'll just write the equation. 2x square plus x plus 2 is equal to a into x plus 1 whole square plus b into, I'll write it as x into x plus 1 plus c into x. So this is your equation 3 now. So substituting x is equal to 0, you will get it as 2 is equal to, so this is 0 plus 1, 1 square is a, so you will get a, plus b into 0 is 0, c into 0 is 0. So therefore, you got a is equal to 2. Next, you can substitute x is equal to minus 1. So therefore, put x is equal to minus 1 in equation 3. So if you put minus 1 whole square, this is 2 minus 1 plus 2. So minus 1 plus 1 cancel, a becomes 0. Minus 1 plus 1 cancel, b becomes 0. C into minus 1 is minus c. So you will get plus 1 plus 2, 3. So c is equal to minus 3. Next, we can choose. We have already taken x is equal to 0. So therefore, I don't have any linear factor to equate to 0. I'll use the concept of equating the coefficient of x square. So now, equating coefficients of x square in equation 3. So you have x square term here and its coefficient is 2. Now x plus 1 whole square means it is x square plus x plus 1. So when you multiply with a, you will get it as ax square. So here you have a coefficient for x square, that is a. Here you have x into x, that is nothing but x square. So that is, you will get b here. Here there is no x square, so you can just leave. So you got the equation in this form, 2 is equal to a plus b. A you got as 2. So what happens here? 2 is equal to 2 plus b. So 2 get cancelled. So therefore, b is equal to 0. So now substitute a, b, c in equation 2. So what was our equation 2? A by x plus b by x plus 1, c by x plus 1 whole square. Just substituting it, we get 2x square plus x plus 2 divided by x into x plus 1 whole square. So value of a is 2, so it is 2 by x. B is 0, 0 by anything. So if you put 0 here, 0 by anything is 0. Next you have c, c value is minus 3. So if you put minus 3 here, equation becomes minus 3 divided by x plus 1 whole square. Now equation 2 is complete. We'll just substitute the value of this proper rational function in equation 1. So what was our equation 1? That is x square minus 2 divided by x into x plus 1 whole square, 1 minus we had. So in the place of this, we have replaced this one. So we will get 2 by x minus 3 by x plus 1 whole square. So after multiplying, we get x square minus 2 divided by x into x plus 1 whole square as 1 minus 2 by x plus 3 by x plus 1 whole square. Thus, we have resolved the given rational fraction. So at last, we come for the simple. So here we have x plus 1 whole square and x plus 2. So just write it as a divided by x. So the last problem, x divided by x plus 1 whole square, x plus 2. Here we have a repeated linear factor. We have to write this as a divided by x plus 1 plus b divided by x plus 1 whole square plus c divided by x plus 2. Take this as equation 1. Now multiplying the equation with x plus 1 whole square into x plus 2. Here we are left with x. So here I'll get x plus 1, x plus 2. Here I'll get b into x plus 2. And here it is x plus 1 whole square. So this is equation 2 now. Now equate to 0. X plus 1 is equal to 0. X plus 2 is equal to 0. This will get x is equal to minus 1. X is equal to minus 2. So just put x is equal to minus 1 here. So put x is equal to minus 1 in equation 2. What we get? Minus 1 is equal to minus 1 plus 1 becomes 0. So therefore a complete term is 0. And here b into minus 1 plus 2 is 1. And here c becomes 0 because minus 1 plus 1 cancels. So now we are left with b is equal to minus 1. Next we will equate x is equal to minus 2. So put x is equal to minus 2 in equation 2. So what happens if you put minus 2? Minus 2 is equal to, here minus 2 plus 2 cancel. So there is no a term. Minus 2 plus 2 cancel, no b term. But here you will get minus 2 plus 1 as minus 1 whole square. So c into minus 1 whole square. So therefore the value of c you will get it as minus 2. So now we got b and c. To find a, any methods, choosing x is equal to 0 or equating the coefficient of x square. So I'll use equating coefficient of x square in equation 2. So this is your equation 2. Here there is no x square term. So therefore here it is 0. Here it is x plus 1 into x plus 2. When you multiply, you will get x square and the constant here is a. For b, it is only bx, so no x square. And for c, you get x square, so therefore c. So here a is equal to minus c, you will get the value of c is minus 2. So therefore minus of minus 2 is plus 2. Or you can put x is equal to 0 in 3. And find a. This is also applicable. So now a is equal to 2 you got. So when you substitute this in equation 1, what I get? X divided by x plus 1 whole square into x plus 2 is equal to. So a by x plus 1. So the value of a is 2. 2 by x plus 1. Value of b is minus 1. So here it is minus 1 divided by x plus 1 whole square, and value of c is minus 2. So it is minus 2 divided by x plus 2. So we have resolved it. So this is how we will resolve the given rational function into simple partial fraction. So whenever an improper rational function is given, make sure that first you must convert them in as a sum of polynomial and proper fraction, as in the case of question 2 and question 3. Suppose if it is already in the proper fractions like this, that is degree of the polynomial in the numerator is less than degree of the denominator, then it is proper rational function. Then we can write it as a simple partial fraction. Just find ABC and substitute it back. So this is how we will resolve whenever a proper and improper rational function is given with in the denominator having repeated linear factor and non-repeated linear factor. So we will take few more problems in the next section. Until then, keep watching, keep learning and keep exploring. Thank you.